Good morning, students. I, Asif Mundra, again welcome you all to Knowledge High School, Anand. In physics, today we will start our first chapter. Title of chapter is Motion in a Straight Line. So first of all, we will understand what is title. First of all, motion. What is motion? Yes, you know about motion. Okay, when birds are flying, earth is rotating around sun, air is flowing, vehicles are moving on road, leaves are falling from tree. These all are examples of motion. But how to define motion? What is the definition of motion? How to write? See, motion is change in position of an object with time. For example, I am object. Another object is this stage. Right now, I am not changing my position with time. See, time is passing. But with respect to this stage, I am not changing my position. It means I am in rest condition. I am stationary. But now, with respect to time, with respect to this stage, if I change my position, then yes, I am said to be in motion. Then what is motion? Motion is change in position of an object with time with respect to some another object. Okay? Motion can be of several types. Linear motion, chalk falling down, it is linear motion. Vehicles are moving on straight road, linear motion. Rotational motion, fan is rotating, rotational motion. Earth is revolving around sun, moon is revolving around earth. Yes, rotational motion. Vibrational or oscillatory motion. What is vibrational or oscillatory motion? Vibrational motion or oscillatory motion means motion of simple pendulum. You know what is simple pendulum? Yes, motion of simple pendulum is called oscillatory motion. Swing. Okay, swing. It is also one example of oscillatory motion. What is vibrational motion? Vibrational motion means particle performs to and fro motion about a point. Okay, so it is called vibrational motion. In this chapter 3, we have to study only linear motion. Rotational motion we will study in chapter number 7, and vibrational motion, oscillatory motion we will study in chapter number 14. In this chapter, we will focus only on linear motion. In this chapter, we shall confine ourselves to study the motion of object along a straight line, and which is also known as rectilinear motion. What is rectilinear motion? Motion of object along a straight path. Is called rectilinear motion. Now see, in this chapter, we have to deal with numbers of objects. A person is moving, a vehicle is moving, sun is rotating in galaxy, earth is rotating around sun, some birds are flying, 2 trains are moving. So, how to deal with object in this chapter? For that, first of all, we have to understand what is particle. See, what is particle? We shall treat the object in motion as a particle. How to consider some object as particle? Students, I can also consider earth as a particle. Now question arises, earth such a large object, and sir is telling we have to consider earth as a particle. Yes, we can consider some object as particle when with respect to their size, distance between them is very large. We know, yes, sun and earth, they are very large in dimension. But distance between sun and earth, it is very large comparative to their dimension. So due to this reason, we can consider them as particle. I can also consider myself as particle. I can also consider yourself as particle. If distance between us is larger than our sizes. Okay, so here in this chapter, we will consider each and every object as particle. Okay, one particle is moving, one particle is in rest condition. Okay, so what is particle? A particle is a point-like object having some mass. It is a point-like object. Clear? So in this chapter, in each and every system, we will consider some object as a point. Now, some definitions are there, branches of physics. See, first, kinematics. What is kinematics? A branch of physics dealing with motion without considering its cause. See, for example, I have this chalk. If I drop this chalk, it is moving in downward direction. Then I have to only study motion of this chalk. From which height chalk is dropped, what is velocity gained by chalk, what is acceleration. Okay, so only study of motion without its cause. In this case, what is cause? This chalk is falling down due to gravitational force. So in study of kinematics, we do not have to consider its cause, that is gravitational force. Another example, if vehicle is moving on a straight path on road, then yes, we have to study only its motion. Yes, vehicle is moving, from which point it is starting, at which point it will end, with what speed it is moving, in which direction, with what acceleration. Then such a study is called kinematics. What is cause? Cause means how vehicles are moving due to engine, how engines are working. We do not have to consider such causes in study of kinematics. Okay, so very simple. Kinematics, a branch of physics dealing with motion without considering its cause. What is second branch? Dynamics, a branch of physics describing motion along with its causes and properties of a moving body. So now if I say I want to study dynamics, then I have to ask each and every question. Yes, vehicle is moving, with what speed? With acceleration. Why vehicle is moving? So yes, your answer is due to engine. How engine works? Engine works, thermal energy is converted in mechanical energy. How thermal energy is converted in mechanical energy? Yes, if we study its cause, then this branch of physics is called dynamics. Another example, this fan is rotating. So if I study only this fan, then it is called kinematics. But if I ask, okay, why this fan is rotating? So yes, your answer is, sir, electrical energy is converted in mechanical energy. It is its cause. If we study this cause, this branch of physics is called dynamics. Clear? In this chapter, we will study only kinematics. From laws of motion, we will start dynamics. Mechanics, kinematics and dynamics are collectively known as mechanics. So these are three branches: kinematics, dynamics and mechanics. Clear? Okay. Now what is motion? Again, motion means change in position. But what is position? First of all, try to understand what is position. See, I am taking one example. It is classroom floor. A for Asif sir is standing here. I have 4 students in each corner. And if I ask them, what is distance or what is position of Asif sir with respect to each and every student. Then yes, from this corner, student will say, sir, Asif sir is 1 meter away from me. Another student from this corner will say, sir, Asif sir is 3 meter away from me. This one 4 meter and this one 5 meter. Yes, each and every students are right, but their answers are different. So how to make uniformity? Okay, all answers are uniform and same. In order to specify position, we need to use a reference point and a set of axes. What is reference point? Reference point is a point from where you have to take observations. If I say all students are at this corner, then for each student reading is same. Yes sir, Asif sir is 1 meter away from me, 1 meter away from also another student. Clear? So if I select this point as reference point, for all students answer will be same. So it is necessary to specify reference point. What reference point we will consider in this chapter? See, a rectangular coordinate system consisting of 3 mutually perpendicular axes, x, y and z axis. The point of intersection of these 3 axes is called origin, and this origin serves as the reference point. So now in this chapter, in 4th chapter, in next chapters, we have to take a reference point to choose or to find position. First of all, you have to choose some reference point, then you can find position. Okay, here we will take origin, intersection of 3 mutually perpendicular axes, as reference point. So if you are given any system, any object, you have to find or you have to measure its position with respect to origin. Okay, the coordinates x, y, z of an object describes its position of the object. X, y and z. X, it is x coordinate on x-axis. It is distance from origin on x-axis, in x direction. It is distance of object or position of object in y direction, and it is in z direction. We will study in the next topic in detail, don't worry. Okay, to measure time we use a clock. Okay, because we have to measure change in position with time. So this coordinate system x, y, z mutually perpendicular axis along with a clock constitutes a frame of reference. Frame of reference is a point or axis from which observer takes its observation. A place or a point from where observer takes his observation is called frame of reference. Okay, now if the coordinates x, y, z of particle, if one or more coordinates of an object changes with time, we say it is in motion, otherwise it is in rest. For example, initially coordinates of a particle 3, 4 and 5 means 3 meter away on x-axis from origin, 4 meter away on y-axis from origin, 5 meter away on z-axis from origin. So if it is its initial position and if its final position is 3, 4, 6, to see from this we can say 3, 4, x and y coordinates, they are as it is. Only one coordinate is changed, that is z coordinate. So when only one coordinate changes, such motion is called one-dimensional motion. And for such one-dimensional motion, we will select or we will choose only one axis. Similarly, if initial coordinates are 3, 4, 5 and it is 3, 6, 7, then here two coordinates y and z they are changed, means such motion is called two-dimensional motion. If three coordinates are changed, then it is called three-dimensional motion. It is called three-dimensional motion. Now you have to make one list. What is example of one-dimensional motion, two-dimensional motion and three-dimensional motion? Clear? Understand what is importance of frame of reference. Frame of reference means from where you take observation. See, for example, here it is a bus. It is a bus. Yes, we will consider that as physics. It is a bus. In bus, there are two students, A and B, sitting. Okay, and this bus is in motion. Another person C is on ground. Another person C is on ground. For A and B, frame of reference is bus. For C, frame of reference is ground. Clear? Okay. A and B, they are stationary in bus. With respect to A, B is stationary. With respect to B, A is stationary. But as frame of reference is changed, with respect to C, A and B, they both are in motion. If A observe B, then he will find that B is stationary. But if C observe B, then C will find that B is in motion. Such difference is due to selection of frame of reference. Selection of frame of reference. Clear? So it is about some basic notes, fundamentals of motion. What is motion? What is particle? Kinematics, dynamics, mechanics, how to define position, what is frame of reference, and what is one-dimensional motion, two-dimensional motion and three-dimensional motion. Pause your video, write down from board. My WhatsApp number is given. Send notes on my WhatsApp number, and if you have any doubt, contact me on this number anytime. I will solve your doubt. Okay student, એક ઇમ્પોર્ટન્ટ મેસેજ છે ફોર યુ. અત્યારે આ જે કંઈ બી રેગ્યુલર સેશન્સ ચાલે છે એના રિલેટેડ વર્કશીટ, અસાઇનમેન્ટ તમે અમને જે રિપ્લાય આપ્યા છે અને તમારા નંબર જે ગ્રુપમાં એડ થશે, વોટ્સએપ ગ્રુપ બનાવવામાં આવશે અને એ વોટ્સએપ ગ્રુપમાં જેટલા બી લેક્ચર્સ સ્ટાર્ટ થઈ ગયા છે, જેટલા બી લેક્ચર્સ થઈ ગયા છે એના રિલેટેડ વર્કશીટ અને અસાઇનમેન્ટ મોકલવામાં આવશે, જે તમારે સોલ્વ કરવાના છે અને એના સોલ્યુશન અમને મોકલવાના રહેશે. સો એ વોટ્સએપ ગ્રુપમાં તમે છો કે નથી એ એક વખત મેનેજમેન્ટ સાથે ખાતરી કરી લેજો. જો તમે એ વોટ્સએપ ગ્રુપમાં એડ થશો, એ વોટ્સએપ ગ્રુપમાં એડ હશો, તો તમને ડેલી બેસિસ પર વર્કશીટ એન્ડ અસાઇનમેન્ટ એન્ડ ડાઉટ સોલ્વિંગના સેશન્સ મળતા રહેશે.